Today I'm going to explain the concept of Gamal encryption. Myself Kavya, Assistant Professor, Department of CSC, Cambridge Institute of Technology, Bangalore. Gamal encryption, it converts the plain text into a ciphertext. Here there are two ciphertexts, that is meaning C1 and C2. It is similar to a RSA algorithm and it is one of the example of asymmetric key cryptography. It uses two keys. One key is used for encryption and another key is used for decryption. Public key is used for encryption and private key is used for decryption. Okay, there are three steps we need to follow in order to perform an Gamal encryption. Step one is nothing but a key generation. It uses a large prime number P and a generator G in ZP. ZP is nothing but a group. Generator G is nothing but a generator of P, and P is nothing but a prime number which is divisible by 1 and itself. The private key is nothing but a. It should be greater than 1 and it should be less than P minus 1. The public key is a triplet P comma G, generator of P, and E is a public key. In order to use, it is used to convert a plain text to a cipher text, and it is being calculated by using a formula E equals G to the power of A mod P, where G is a generator and A is a private key. And let P comma G comma E be a public key of a. The private key is nothing but A and the public key is nothing but P comma G comma key. Step 2, coming to step 2, encryption. Encryption means you need to encrypt some message. That means you should convert the plain text to a cipher text. Let us take one example. Bob and Alice. Bob wants to send some message to the Alice, means Bob should use the Alice public key in order to encrypt the message. So Bob does the following things, and first thing is he need to choose a random number R such that it should be greater than 1 and it should be less than P minus 1. And also one more condition it has to satisfy. It is nothing but a R should be relatively prime to P minus 1. That means the GCD of R comma P minus 1 should be equal to 1. Next step, he computes C1 is equal to G to the power of R mod P, and also uses A's public key in order to compute C2, and also encrypts the messages by using a public key. Message M into E to the power of R mod P, where M is a message which is less than P minus 1 and it is chosen by the Bob in order to send from Bob to Alice, and E is nothing but a public key of Alice, and R is chosen by the Bob, which is relatively prime to P minus 1, and perform a modular operation mod P, which gives you the remainder. Bob sends the ciphertext C1 comma C2 to the Alice. Next, third step is nothing but a decryption. In order to decrypt the ciphertext received by the Bob, Alice uses the private key and computes C1 to the power of A minus A. A is nothing but a private key star C2 mod P and recovers the message whatever it is being sent by the Bob. These are the three steps we are going to perform in the Gamal encryption. Step 1 is nothing but a key generation. Step 2 is nothing but a encryption, and step 3 is nothing but a decryption. Step 1, we are using a private key and public key. Private key will be chosen by a person who wants to send a message. Any person, it's not a person who wants to send a message. Any person can select a private key and generate a public key by using a private key. Next, step 2, encryption. In Gamal encryption, we are going to convert the message into two ciphertexts, that is C1 and C2. How it is be done by using these steps. And next, step 3 is nothing but decrypt the received ciphertext and obtains the message by using this formula. Let us learn this Gamal encryption with one example. Let us take P equals 131 and G equals 2, which is a generator of 131. And the first step is A's private key should be chosen such that we have taken A equals 97. Corresponding public key is nothing but a 2 to the power of 97 mod 131 equals 14. How you have got? With the help of the square and multiply method, we can solve this problem and obtains the remainder after performing a mod 131. We have got it as 14, and the message to be sent is nothing but 75. Here we have taken example from Bob to Alice. Bob has to send 75 to Alice. What Bob has to use? Bob should use the Alice private key. Sorry, Bob should use the Alice private key. Sorry, public key. Alice public key is nothing but 14, right? In order to encrypt the message and obtains the ciphertext. And the what B has to choose is random number R such that it should be relatively prime to P minus 1. That means the GCD of R comma P minus 1 is 130 should be equal to 1. We need to trial and error method. We need to check with 2. 2 comma 130 GCD is not 1. 3 comma 130 GCD is not 1. 4 comma 130 GCD is not 1. In the similar way, once we chosen 33 comma 130, the GCD of 33 comma 130 is equal to 1. So the R value chosen is nothing but 33. One condition is satisfied. Another condition, it should be greater than 1, yes, and it should be less than P minus 1. It is less than 130, yes. So R is nothing but 133. First step in order to find out C1 is C1 equals G to the power of R mod P. So 2 to the power of 33 mod 131. Performing using the square and multiply method, you will get the remainder as 103. C2 is nothing but the message which I was chosen is 75, and we have taken Ali's public key is nothing but 14. 14 to the power of R we have chosen is 33, and once we perform mod 131, we are getting a ciphertext as 51. What the Bob will send 103 and 51 to the Alice. Coming to the decryption, Alice should compute using this formula and recover the message, that is M, whichever is sent by the Bob. In order to perform a decryption, Gamal encryption uses a Alice private key, right? The Alice private key is denoted by A. So A, the C1 to the power of minus A star C2 mod P. C1 we have got is 103 to the power of minus 97 star C2 is 51 mod 131, which is equivalent to 103 to the power of 97 whole to the power of minus 1 we can write down into 51 mod 131. Once you can perform this using a square and multiply method and find out the value of 103 to the power of 97 mod 131 will get you some number. That number inverse mod 50 into star 51 mod 131 will gives you the 40. That means inverse of mod, that number whatever you have calculated, the inverse of mod 131 will gives you the number 40. 40 into 51 as it is, you write down mod 131. 40 into 50 for 51 into performing mod 131 will gives you the remainder as 75. The message which was sent by Bob was 75, and the Alice also have got the message 75. Thank you.